Hey, how's it going, guys? Well, I trust you all had a good Christmas break, and now it's time to try to get back on our chemical reactions. We have 5 types of chemical reactions we're going to do today. You can see the heading right here, and um, we're going to just break down each type and give an example of each type. And in the future, we'll actually use these in the lab. You know, each try to give you a sample of each one. But today, let's just get the basic outline of the 5 types. Some of them you've already seen before. For instance, the first one is a synthesis reaction. And the synthesis reaction is when 2 or more substances combine to make something new. Synthesis, remember, like in photosynthesis, the last reaction, in fact, that we did was making something from light as God designed it. You know, you've got light coming into the plant, into the chloroplast, triggering a reaction between the carbon dioxide and the water, and making glucose. And of course, oxygen is another byproduct. But you've got the 2 substances there making something more complex, the glucose. In this case, though, I just took something simple like hydrogen and oxygen and made water. So this is a synthesis reaction. Okay, so take these notes down as you go and just get an example of each one. And then we'll be able to identify them on other chemical reactions and be able to tell what kind they are as we go. Now, the second type is decomposition, and really it's just right the opposite of synthesis. So you're starting with one substance and breaking it into 2 or more. So you could just take the water, you know, the formation of water, and you could just turn it around backwards. And so you start with H2O and breaks apart into hydrogen and oxygen. Technically, this is called electrolysis. Electrolysis is the breaking apart of the hydrogen and oxygen in a water molecule. And people do that in order to burn the hydrogen and then release the oxygen. Um, Also, you can use it in a process of taking rust off of things. I even have an electrolysis tank. And so you put some more ingredients in there with the water, and you remove the rust from cast iron and other things. And I'll probably bring that in the future here to school and show you how that works as one of our labs and how to set that up, and then we'll watch it work. And so anyway, that's a decomposition reaction. Third type, and you'll see all these on Schoology also listed there. And if you want to take it off of Schoology, you can. But the definitions are here on the video. So third type is going to be a single displacement. Single displacement reaction. And that's when you have a compound and a single, so I could just write it this way, one substance plus one element. Reacts. And the substance or the compound, we could call it, let's write that on here, one substance or compound reacts with one element. And then the element will displace part of the compound. So here's how it looks. Let me just write out an example for you. In fact, we'll do one that we're going to do in the lab. We'll take hydrochloric acid and we'll react it with some aluminum And what will happen is the aluminum will knock the hydrogen off of this compound because it's more reactive than the hydrogen. And so the aluminum will kind of take over and make aluminum chloride, which you probably remember aluminum has a positive 3 charge, chlorine with a negative 1, so it's got to be AlCl3. It's going to be 3 chlorines for every aluminum. And then the hydrogen being displaced, hence the name, single displacement, will be released as a gas. In fact, you could put that little label that we saw on the last video in parentheses there, little g, for gas. So this is a single displacement reaction. Once again, the aluminum is knocking the hydrogen out, and it combines with the chlorine to make aluminum chloride, and the hydrogen, of course, is released. And there's going to be 100 of those different single displacement reactions that we're going to look at and label, and that's just one example of one. So we also have a double displacement reaction. So you might be able to guess what's going to happen with the double displacement. It's going to be just like the single. However, we will have two. So two compounds are going to react and their elements, their positive ions, will swap places. Okay, let's look at an example of that. You'd have the sodium hydroxide reacting with iron, we'll say iron chloride, which will be FeCl2. Okay. And I think I'll do this one with this pink color here. Sodium hydroxide and iron chloride, and that's going to yield. Well, what's going to happen? Well, your two positive ions, the sodium and the iron, are really going to swap places, okay? So you end up with iron hydroxide. Got to have your parentheses because it's a polyatomic ion. So say you got two hydroxides there. Plus sodium chloride. And of course you're familiar with that. So in a double displacement, you have two elements switching places or displacing one another. You see the iron going with the hydroxide, so you write it iron hydroxide here. And you see the sodium leaving the hydroxide and going with the chlorine, so you end up with sodium chloride. So that's an example of a double displacement reaction. The fifth and final type is the, let's see if you can still see that on there, is the combustion reaction. And one that we will work on in the lab also, combustion. Combustion reaction is when you take hydrocarbon like methane or propane, gasoline, kerosene, toluene, acetone, mineral spirits, all those hydrocarbons, and you ignite them, well, then of course that's going to make a explosion of sorts. But the hydrocarbon is ignited, so that's a combustion reaction. Ignites, burns. Okay, let's get an example. Well, you've seen some of this before. Once again, I got to make sure this fits down here. Okay, let's just do a very common one we're going to see in the lab, the CH4. Who remembers what that gas is? Methane. Very good. Okay, so methane plus what must be present in order for it to burn? You're right again, oxygen. And that's going to yield what? So we got methane plus oxygen. What's that going to make over here? Well, surprisingly, it makes carbon dioxide and water. Now you don't see the water necessarily, although we will see some little droplets of water forming in a test tube if we get a chance to run that reaction. And you can see sometimes water forms as a precipitate, but sometimes it just goes as water vapor. So when you burn like gas in your home, like on the stove, then you don't see water floating off of the flame, but nonetheless, it's putting off water vapor. So methane plus oxygen yields carbon dioxide and water. So one way to recognize a combustion reaction is to look for the products. It's always going to have carbon dioxide and water as products in the reaction. Okay? So the 5 types then here that we're going to be familiar with. There are other reactions as well. There's a oxidation, reduction, there's acid-base reactions, but we may look at those later in the year, but we're going to focus on these 5 for now. So get the notes on those, get examples for each, and then we'll come back with some more teaching on that maybe tomorrow. All right? God bless.